learn together, pass together, grow together. So, today we learned that Ethernet isn't the cable. Most people look at an RJ45 cable and say, oh, yeah, Ethernet cable. That's one of those things we have all said so many times that it feels true, even when it's technically off. The cable is the cable. Ethernet is a language, the communication standard, the rules everybody agrees to follow so device can actually talk to each other. Wow, that matters more than it sounds like it does. Because when I start building example shop, I don't just need stuff plug in. I need it plugged in and speaking the same language. Our access points, our switches, our laptops, our servers, even that random smart device somebody swears is totally business critical. They all need a shared standard or the whole thing falls apart. So here is the thing, when you are learning networking, it's really easy to get obsessed with the physical stuff first. Cables, ports, blinky lights, hardware. That's fine. I love that stuff too. But if you miss that fact that standards are what make all those things interoperable, you are going to struggle the moment something breaks you and you have to troubleshoot it for real. Why standards exist it at all? Ethernet becomes the dominant standard because the networking world desperately needed everybody to agree on how communication should happen. Different vendors were making different devices, and if every company invented its own private language, we had have a travesty on our hands. You couldn't connect a computer from one company to a switch from another and expect anything useful to happen. Standards fix that. Historically, Ethernet goes way back to Xerox in 1970s. Then it was standardized by the IEEE, which is the Institute of Electrical and Electronics Engineers. Mouthful. I know everybody just say IEEE because life is too short. The movement part is that they took a good idea and turned it into a shared rule book the whole industry could use. And that's why a home built PC can talk to Roku, which can talk to an Apple TV, and which can talk to a switch from some vendor you have never heard of. Different manufacturers, different hardware, same standard. That's awesome, right? The internet and modern networking only work at scale because everybody agreed to the same core language. When I say Ethernet is a standard, I don't mean some vague, fuzzy idea. I mean it defines very real concept that shows up everywhere in networking. Two of the biggest ones are MAC address and historically CSMA CD. If those terms looks weird, hang on because they are not as scary as they sound. A MAC address is a unique hardware identifier assigned to a network interface card, the network port or wireless adapter in a device. It's usually shown as 12 hexadecimal characters. Hexadecimal just means it uses numbers 0 through 9 and letter A through F. That address is how devices are identified at the local network level and switches use it constantly. So imagine our example shop, we have got a black server for media, employee laptops, wireless access points, maybe some back office machines. Every one of those devices has MAC addresses. The switches learns those addresses and start building a map so it knows where to send traffic. That way, when one device wants to talk to another, the switch can forward the data intelligently instead of blasting it everywhere. And I don't want you to miss how huge that is. A switch isn't just a dumb box with ports. An Ethernet switch is a device that follows the Ethernet standard and makes communication efficient by learning who is where. Without that, our example shop never gets noisy fast. And noisy networks become slow, weird, painful to troubleshoot. Okay? So, networking gets a lot easier when you remember that everything, and I mean everything, eventually becomes zeros and ones. Video, audio, web traffic, credit card transactions, security camera footage, it's all just binary being converted, transmitted, and rebuilt on the other end. If we are using copper cablings, those zeros and ones move as electrical signals. If we are using fiber, they move as pluses of lights through glass, and different medium, same basic goal. We are transporting digital information from one place to another in a way both ends understand. That's why a standard matters so much, because the physical medium alone doesn't tell device how to interpret and manage that communication. Okay. Back in the day, before switches become the norm, networks often used hubs. A hub looked like kind of similar to switch, but it was nowhere near as smart. It didn't learn addresses. It didn't make forwarding decisions. It just repeated incoming signals out every port. One device talk and everybody hear it. You can probably use the problem if two devices try to transmit at same time, their signal could collide. That's where CSMA CD comes in, which stands for Carrier Sense Multiple Access and Collision Detection. I know absurd name, but the idea is simple that device listen before sending, detect it if a collision happen. They wait and then retransmit. That system worked, but it wasn't exactly glamorous. Even collision slowed the network down because data had to be resent. In smaller, older shared environments, that was just part of life. Today, we modern switch Ethernet networks, so we don't deal with collision the same way in normal operations. But the concept still matters because it explains where Ethernet come from and why smart devices changes everything. If you remember one thing from this lesson, remember this: Ethernet is not a cable, it's a standard. Yes, people call twisted pair cabling Ethernet cable at all time. You will hear that everywhere, but underneath that usual language is a much more important truth. Ethernet is a shared set of communication rules that lets the devices in our world actually work together. For example, shop, that's everything. Our wired devices, our wireless systems, our servers, our endpoints, they all depends on standard to stay connected and reliable. If I don't understand that, then the moment the network starts acting weird, I'm just poking at blinking lights and hoping for a miracle, and that's not a strategy, right? So we have got the foundation. We know there are physical connections, and we know there are standards that defines how communication happen over those connections. Once you understand the standard, you can start understanding how the lower thing of networking actually behave when real traffic starts moving.